is Jamie Wong. I'm a research scientist at Tisch, MS Research Center of New York. I joined the center in 2015 after completing my postdoctoral fellowship at Mount Sinai, and prior to that, my PhD in neurobiology at the University of California, Irvine. During my first meeting with Dr. Siddiq, he explained that there are 15% of MS patients who are diagnosed with primary progressive MS, or PPMS, and that treatments for PPMS are generally ineffective. The biggest complaint that he hears from these patients is that they feel as though no research is being done to help them. During our discussion, Dr. Siddiq and I came to the conclusion that the single biggest obstacle which was preventing progress was the lack of an experimental model to study primary progressive MS. I decided to see what would happen if I tried injecting spinal fluid taken from primary progressive patients directly into the cervical spinal fluid or intrathecal space of a mouse. This is a challenging procedure, especially since a mouse is so small, and I had to be very careful not to injure the spinal cord. I also injected spinal fluid taken from relapsing remitting and secondary progressive MS patients, as well as spinal fluid taken from healthy people as controls. Remarkably, what we observed was that only the mice that were injected with spinal fluid from primary progressive patients developed muscle weakness, which was incredibly exciting and immediately prompted the question, what is it in the spinal fluid of primary progressive patients, but not in the other forms of MS, that is causing this problem? But first we wanted to make sure we were on the right track, so we examined the spinal cords of these mice that developed weakness, and we found that there was a loss of myelin, which is the insulation around the nerve fibers, and exactly what you see in MS patients. We also looked for other hallmark features that are seen in primary progressive patients, such as scar formation or sclerosis, and damage to the nerve fibers themselves. These are called axons. And we found all of these features only in the mice injected with PPMS spinal fluid. For us, this was our first breakthrough moment, because now this confirmed that we had developed a mouse model which mimics what we see clinically and pathologically in humans with primary progressive MS. This model allowed us to make a major discovery, which was that PPMS patients have antibodies in their spinal fluid that are responsible for causing weakness and pathology. We performed a series of experiments where we specifically removed antibodies from the spinal fluid and found that it no longer caused any problems when we injected it into the mice. Then, when we injected only the antibodies from PPMS patients, we found that the mice developed all of these PPMS-like symptoms. Because of these exciting developments, our ongoing research is now focused on discovering how these antibodies cause weakness and what targets these antibodies are binding to. We believe that this will help design treatment strategies to remove specific antibodies which are causing damage, and ultimately, our hope is that this will lead to the development of an effective treatment for PPMS.